Today we're talking about a major moment in space exploration as NASA rolls out the Artemis II rocket, marking a crucial step toward the next crewed mission to the moon. This event is not just about moving a massive rocket across a launch facility. It represents years of planning, testing, setbacks, lessons learned, and renewed ambition to send humans farther into space than they have gone in decades. Artemis II is the first mission in NASA's Artemis program that will carry astronauts aboard the Space Launch System rocket and the Orion spacecraft. While ArtemisII proved that the hardware could fly safely without a crew, Artemis II is about human lives, human decisions, and human experience beyond Earth orbit. That alone makes this rollout a historic milestone. The rollout itself involves moving the fully stacked Space Launch System, often called the most powerful rocket ever built, from the vehicle assembly building to the launch pad. This slow journey, traveling at less than 1 mile per hour, might look uneventful on the surface, but it is one of the most critical stages before launch. Every vibration, every connection, and every system is monitored closely. The Space Launch System, or SLS, stands taller than the Statue of Liberty and generates more thrust at liftoff than the Saturn V rockets that carried astronauts to the moon during the Apollo era. With Artemis II, this rocket is being prepared not for a test, but for people who will ride it beyond Earth and back. At the top of the rocket sits the Orion spacecraft, which will carry the crew. Orion is designed to support astronauts for deep space missions, with advanced life support systems, radiation protection, and the ability to travel farther from Earth than any human-rated spacecraft before it. Unlike spacecraft designed only for low Earth orbit, Orion is built for the harsh environment of deep space. The Artemis II mission will not land on the moon, but it will take the crew on a long journey around it. The spacecraft will travel tens of thousands of miles beyond the moon, testing navigation, communication, and life support systems in real deep space conditions. This mission is about proving that humans can safely operate far from Earth again. Rolling out the rocket ahead of this mission shows NASA's confidence in the progress made since ArtemisII. That uncrewed mission faced delays, weather challenges, and intense scrutiny, but it ultimately succeeded in orbiting the moon and returning safely to Earth. Artemis II builds directly on that success. One of the key reasons this rollout matters is that it signals a transition from testing hardware to testing human endurance and teamwork. Spaceflight with a crew introduces variables that cannot be fully simulated on Earth. Human reactions, decision-making under pressure, and real-time problem-solving are essential parts of this mission. The astronauts selected for Artemis II represent a diverse and highly experienced team. They include veterans of spaceflight as well as astronauts preparing for their first journey beyond Earth orbit. Together, they will test not just the spacecraft, but NASA's readiness to support humans in deep space once again. This mission is also symbolic. It marks the first time humans will travel to the moon's vicinity since the Apollo 17 mission in 1972. More than half a century has passed since humans last left low Earth orbit, making Artemis II a bridge between past achievements and future ambitions. The Artemis program as a whole aims to establish a sustainable human presence on the moon. Unlike Apollo, which focused on short missions, Artemis is designed for long-term exploration. The moon is seen as a testing ground for future missions to Mars and beyond. Rolling out the Artemis II rocket shows how far the program has come despite challenges. Technical issues, budget pressures, and shifting timelines have all tested NASA's resolve. Yet the agency continues to move forward, guided by lessons learned from each delay in test. The rollout process itself is carefully choreographed. Engineers monitor structural integrity, fuel systems, avionics, and communication links as the rocket moves to the pad. Even small issues can cause delays, because safety margins for a crewed mission are extremely strict. Once at the launch pad, the rocket will undergo additional tests, including fueling rehearsals and final checkouts. These steps ensure that every system performs as expected before astronauts ever climb aboard. Nothing is rushed at this stage. Public interest in Artemis II has been steadily growing. For many people, this mission represents a return to bold exploration and a reminder of what humanity can achieve when resources, expertise, and vision come together. The Artemis II mission also plays a role in international cooperation. NASA is working with partners from around the world, including space agencies that contribute technology, research, and future mission plans. This collaborative approach reflects how modern space exploration is increasingly global. The moon itself remains a powerful symbol. It is close enough to reach but challenging enough to push technology and human capability. Artemis II is about relearning how to journey to this familiar yet distant world in a modern context. Another important aspect of the rollout is the validation of new technologies. While the rocket may look similar in concept to Apollo-era designs, the systems inside are far more advanced. Digital avionics, modern materials, and updated safety systems all play a role in making Artemis II possible. For NASA, rolling out the Artemis II rocket is also a moment of accountability. Crewed missions demand the highest level of reliability, and the agency knows that the world will be watching closely. Success or failure will shape public trust and future funding. Thanks for watching. Don't forget to like the video, leave a comment, and subscribe to the channel.